welcome back. Today, Sinan and I are excited to be speaking with Adam Azzam, AI lead over at Prefect which is a modern data pipeline orchestration company. Adam is also the lead behind an open source project called Marvin, which is helping engineers structure and work better with LLMs. We're going to talk with Adam a little bit about why working with LLMs currently is so challenging, what ambient AI is, and how a vision around ambient AI can change and simplify the developer experience for many. And we're super excited to have him on.
Yeah, we are. It's this is definitely one of those interviews where the practical takes its time in the spotlight and practically intelligent. The idea that LLMs are really inviting more and more developers in, and developers are saying, "Well, how do I make this work with everything?" It's really a cool interview about how we can influence that integration and migration of all these new developers into the AI space. So let's dive right in.
Awesome. Adam, welcome to the pod.
Hey, thanks for having me.
Well, Adam, I'd like to start because when we met, you were giving a talk on some of your work at Prefect, and you said, quote, "The current state of developing with LLMs is worse than when I started working with MATLAB."
Yeah.
Could you give us a little sense of why you said that and why it's so challenging today for a lot of developers who are stepping into this, brave new world of language models to actually build consistent, reliable applications with LLMs?
Yeah, for sure. So thanks again for having me. So when we talked last, it was at GlueCon in Denver, and I was talking about how difficult it is to integrate LLMs into classical software, right? Like if LLMs speak English and software is pedantic and speaks structured types, getting those two things to play with each other is pretty difficult. And the developer experience for working with LLMs started with trying to figure out what functionalities LLMs had. So you had a lot of like prepackaged agents. You had a lot of prepackaged like this thing either does this entire task for you or it does nothing. And you also had this like kind of wild west of like for this one very hyper specific task, you can use our library to maybe get an LLM to work with the rest of your software. And but those are really the only two options that you had. So when we started Marvin, it was really this, well, let's work backwards from how we want software to feel, which is we love the idea of using large language models almost as like a runtime or a virtual machine, something that can understand the nuances of what you're trying to compute without having to write all the business logic yourself. But it is still a strongly typed object because that's how workflows are made, that's how software is made. And so so that's really kind of the mission of what I talked about when you and I first met, which is how do you marry these two ideas of strongly typed semantic interface to LLMs that still kind of saves you from having to write all this business logic yourself. And that's what's really motivated a lot of the choices that we have in Marvin, and happy to talk more about that.
For sure. One thing that you talk about in Marvin is moving towards this concept that you briefly touched upon is this idea of kind of ambient AI and development experiences that are more ambient. Could you touch a little bit about what you mean by that? It's a super nifty concept, so I'd love to talk a little bit more about it.
Yeah. So ambient AI is, I wish I could claim credit for it. It's the phrase was something that we stole from Jim Fan at NVIDIA and OpenAI, where he saw something that we had put out in Marvin, and he was like, "Oh man, this feels like ambient AI. This is how I want AI to feel." And so we stole it wholesale, and now we throw it out everywhere we can. But what he meant, and I think why it was such a good encapsulation of what we're trying to do, is this idea of if we were all writing software a decade ago, it looks very much to how we are writing it today, and we don't want a lot of these like classical design patterns or like the ways that we've spent a decade learning to write software, we don't want a lot of that stuff to go away, right? So if you want to call what we've all been collectively working on for the last 10 or 20 years as like software 2.0, I think is the way that he put it, you still want to marry this together with the advances in what LLMs have brought to us. And so this idea of how do you marry together the design patterns and all the software best practices that we've been building, how do you marry that together with the power of an LLM to sort of understand that fuzzy business logic? Or, and so ambient AI is really this feeling of how can you sprinkle in LLMs so that maybe you're executing a function on an LLM runtime so that it lives in the background and that your code doesn't look like a big old library of prompts that you're smashing together, and that like making a PR is basically like, oh, I'm going to edit, please output this in a structured form, to capital please output this in a structured form. And how do we make our PRs and the way that we build this software more like how we have been for the last decade or two? And how do we let LLMs interface with that software in a way that's kind of invisible, that supercharges our software rather than replacing it? And so ambient AI, I think the way I liked it put was that it operates in the background and it adds superpowers to your classical code, and in that way bridges software 2.0 to whatever software 3.0 looks like. I don't know what it looks like, but we're building the bridge at least for now.
Yeah, and just as an example, I think this is the example that I think was in that tweet you were mentioning from Jim Fan. The idea would be like you would define an object in something like Pydantic. I think the exact example that he was showing was like location, and he would show city, state, country, lat long, just like as a definition of a model, and then you would call that model, and you put a decorator on it in Python with from Marvin, and then you would be able to say, okay, I want location, but instead of saying location, city equals blank, state equals blank, country equals blank, you would say location, and then you would just give it something in natural language like Chicago or San Francisco, or something like, oh, he's from the where the Golden Gate Bridge is, and then Marvin would take over and say, oh, okay, city, San Francisco, country, U.S., state, California. It's that map. And I think that's how I like to think about it, right? So I am someone who comes from not a computer science background, but a mathematical background. And a lot of what pure math is defining maps and structures of maps. And for me, what Marvin represents is this map from to come to your point, the flexible Wild West world of LLMs, where it's like, well, there's this engine back here that we have access to, call it OpenAI, Anthropic, Cohere, whatever. But that engine needs to eventually make the car go. And everything in between the engine and the wheels moving, that's hard. So what I always see Marvin as a way to simplify that connection between an engine and the wheels. And is that how you think about it? Is that how your developers think about it? Like, how do you feel about that?
So I love the analogy, and like as a fellow mathematician, I'd be remiss if I didn't take your analogy and raise you another analogy, which is so there's two ways. I'll encapsulate. I think the way that you phrase it is we're building an English API to software, right? Which is software historically speaks in strong types. Software is responsible for like validation and parsing, and you can build in an LLM to now take unstructured data like user input and be able to map that onto strong types. And so that example of, well, Pydantic has only really been used for, okay, this person put in a lat and a long, let's make sure that it's these things are both floats within these various bounds. But now you can put in, I remember one of the first examples I ever did, I'm from Lincoln, Nebraska, but I put in, I'm from the Midwestern capital that's the seat of a unicameral legislature or something like this. And of course, what I get out is I get the latitude and longitude of Lincoln, Nebraska out of it. And so in that sense, you take this very obscure fact that's obscured behind several layers of inference or deduction, and now you're able to build an English API. The way that maybe nobody would ever talk about Lincoln that way, but we've built an entire industry about, how do we take in the way that, users want to interact with our products, English or their own personal language, and then how do we map that onto actual business logic that we want to build around parsing, validation, etc. The analogy that I think about, so that's first analogy. The second analogy also, which is, so you can appreciate as a mathematician that we don't. Have you guys ever heard this joke before? So how do you kill a blue elephant? You shoot it with a blue elephant gun. How do you kill a pink elephant? Well, you strangle it until it turns blue, and then you shoot it with a blue elephant gun. And the reason why I like this joke is it encapsulates this attitude that we have in math, which is we don't make that much mathematical progress. And so when we have techniques that have solved a problem area, the way that that reverberates through the rest of math is we all find ways of recasting or rephrasing our problems into general sort of solutions that we have, right? Like if you want to show the existence and uniqueness of a differential equation, you recast it as a fixed point problem because we have fixed point theory more or less figured out for that set of problems. And so LLMs, I'll draw it back, which is LLMs have in some sense solved autocomplete problems. And so a lot of what we do at Marvin and what a lot of other folks are sort of maybe doing unintentionally is now we have a bunch of problems that on face aren't autocomplete problems, but we have autocomplete solved. So we're all trying to figure out how do you take these very general problems that have plagued data science for 15, 20 years. So a veteran in this field will be like, we've been solving this since the 80s. Like I granted, right? But when we think about extracting structured text or structured data from unstructured text, now we're all trying to find ways of how do I recast this amorphous, on its face, not an autocomplete problem. Now I go to an LLM and I say, hey, I've got this unstructured this data, I've got the schema of this model, this data model. Can you fill in what these fields are? And so in that sense, we're pushing it down to the field of autocomplete, and then we are trying to parse the responses to bring them back into software. So Marvin is really this idea of we have these classical tasks in data science: classification, entity extraction, getting structured information out, maintaining and updating structured state, just executing functions themselves. These are all things that on face aren't autocomplete problems. And what Marvin does is it sort of transpiles it down to the world of an autocomplete problem, sends it to an LLM and brings it back. And in that way, builds an English API for most classical tasks in machine learning, or like NLP, I'll say.
Yeah, I feel I should give a disclaimer. Mathematicians are not in the business of killing elephants in any capacity. But just But to take your analogy and one up. No, I'm kidding. But seriously, to that analogy, you're right, because in a lot of mathematics, and this ripples out to physics and a lot of other STEM fields, the idea that you have this problem solved over here, and you have the second problem over here, and say, well, it kind of looks like problem A. But maybe not all of it, maybe parts of it, to your point, right? So maybe we say, well, what if we assume some parametric assumption, something about the system, and then, hey, bada bing, bada boom, now it looks like problem A, and we can solve it. But the problem with that is, or at least the consequence is, that map is not usually reversible, right? It doesn't really map onto the entire domain. You can't really say, well, we only solved it partially. And what that might look like on the developer side is, well, we've solved it partially. If we map everything to some auto-regressive, some autocomplete task prompt, how good is that map? Is that map going to be, precise? Is it going to be accurate? Is it going to be, whatever metric you want here? And the other side is, well, and also what are we losing in that assumption? If we map it down to an autocomplete, what areas of the problem are not being solved? Now, to that point, usually the idea is, well, we're still solving non-zero part of it, right? We were either solving zero of it or some of it. In your experience, or at least in your dealings with your users and your customers, what are the types of problems that you find are really great matches for something like Marvin, where you can actually take that task convert it, so to speak, to an autocomplete problem, and you've seen that task solved really well? Or what's a common type of problem that you see a lot of your users are doing?
Yeah. So I think one of my favorite parts about this is like, so every week, like my version of the like call us and install has been just essentially talking with folks who have been like, oh man, like I tried using this library and everything's breaking and I don't understand. And then basically onboarding them onto Marvin in like 45 minutes. And I basically tell them like, yeah, I mean, it's very non-scalable, but such is the sort of business early on. Which is basically like, look, at the end of this call, we're going to have essentially rewritten your entire logic in this. And so I actually have a pretty good understanding of what folks are using for this. So this is basically off the backs of working with maybe something close to like 45 founders at this point. So the big part is zero-shot classification. And I'm sure folks listening to this podcast can piece together what that means, but just to be super clear, building classification when you don't have access to, say, clean training data to build a more classical machine learning model. Essentially what you can do is you can say, look, here's my data, here's my set of labels, what label or what bucket does this fall into? And why this is particularly helpful is there's a lot of times where, let's say that we are, I'm trying to, maybe the best example I can put this is like, suppose we're trying to scrape a bunch of search page results and we're trying to figure out, which one of these things are relevant for me trying to like build comps or comparables for like an investment that I'm trying to make. And so I might go look at 10 web pages, where I might look at like the top 10 Crunchbase results or something like this. And I'm trying to figure out which ones are actually relevant to a company that I'm considering that I'm trying to do more research on. So that's something where like, if you imagine trying to build like a classical data science pipeline of, I've got this company that I'm evaluating and I need to figure out whether or not these 10 other Crunchbase page results are relevant comparables for this new company that I'm evaluating. That's a problem that shifts so much that the idea of building something, setting it in stone, and then retraining it every couple of weeks just doesn't actually fly here. And so what you can essentially do is you can say like, my labels are relevant and not relevant. Here's the context of the problem. I need to figure out whether or not these search page results and their descriptions are relevant to this company I'm comparing it to. And then now you just get literally binary 0, 1, like, yeah, this is relevant, this is not. And then you can go and nav into those pages, scrape them, and bring them back. The other piece is, so that's classification. The other piece is entity extraction. If any of you guys have had the misfortune of doing entity extraction or like getting out structured data, right? Like the way that this normally worked is you prayed that Spacey had like built this in so that you could just, rely on the geniuses at Spacey and their sort of named entity recognition to do this. You got laughed at if you were like, let's use like conditional random fields to see if we can build this out. And often you had to like essentially build more supervised classification methods to be like, cool, is there some proper noun that has something to do in semantic space with this thing I'm interested in? Let me see if I can pull it out. And there are more sophisticated ways of doing this, of course. But now it's as simple as like, here's this Wikipedia page. I want to pull out the names and dates and locations of, all the figures involved in the Manhattan Project or something like that. Now you can literally just say, well, I expect a list of people and a person is defined by these fields. You can point at a Wikipedia page with, say, a data class or a Pydantic model. Now it'll extract it all out. So zero-shot classification, zero-shot entity extraction. And that last piece is just writing very fuzzy business logic. So like, how do you get summarizations out of long strings of text in a way that you can specify like, well, there's a maximum length to this summarization. There is a style of the summarization that I want. There are some key points that I want to have evaluated here. Those can all now be parameters that you put inside of a function. You give a short description in the doc string of what the function could do, and then now you're relying on an LLM to be able to take in those types or those parameters and then output structured information out of it. And so those three pieces around doing zero-shot classification, entity extraction, and then how do you write almost impossible business logic. Those have been some of the most three promising things that folks have been doing with it. There's one asterisk that I'll put here, which is been used a lot, I've seen, for synthetic data generation, right? So summarization is just one way of saying, like, I've got a document and I want to generate a shorter version of it. So it's a generation problem. But now if you're like, we have one user who's building out a platform that helps essentially accelerate the sales cycle for like data tooling, where they noticed that one of the biggest blockers in their experience doing sales was, look, we bring a tool to a user or to a potential customer and they say, well, here's how our data is shaped, here's how our data looks. So if you can build me a sales demo that actually looks, that can actually handle the data that we normally work with, they found that they were able to close those deals much more often than not. And so now they're able to just say, like, great, you've got a customer, you're trying to build a proof of concept for being able to stream this type of user data that they're collecting. Now we can actually mock that data and using an LLM in order to make a more realistic sales demo. And so that's one of my favorite, like, AI, but not in a like high on our own supply version of AI, right? Like, it's a great application of AI for a very classical sales problem that, you know, we've all dealt with.
Yeah, and I really love the mention of zero-shot classification because so in a lot of my kind of one-off lectures that I give on LLMs, I almost always come to the topic of content moderation, output validation, just kind of monitoring what your LLM is saying. And almost every single time I give the example of using zero-shot classification from a model like BART is like the most common one that people think of from Facebook, using their NLI model, their BART model, to do, you know, classify content into buckets of like offensive, non-offensive, toxic, non-toxic, or, you know, anti-Semitic or racist or sexist or whatever. And it's like that, the idea that you can just give the LLM your structured classes and say, here's the raw content, here are the classes I want to map it to, and without training it, without giving it data on what those content pieces look like, it would be able to classify it with you know, depending on your level of, you know, satisfaction, with decent performance. And that idea that you can think about this, because that opens up a whole new world, right? We're talking about all kinds of different applications here. I'm talking about content moderation. We're talking about just structuring, you know, token classification and entity recognition. That is some of the baseline tasks in NLP, right? To your point, and thank you for bringing up conditional random fields before I did. But to your point, this is not an unsolved task, technically. The idea of token classification has not been unsolved. What is different, though, is now we can perform this kind of token classification, entity recognition, on your specific labels. It doesn't have to be a part of speech. It doesn't have to be find the proper nouns. It can be find the, you know, symptoms given a medical sheet. Find the, you know, contract value given a contract. It can be whatever you decide is a label for a token. And I think, and I guess my comment there is, what's hard now is changing your mindset away from that structured entity recognition to, oh, I get to decide what the token labels are? What could they be? And that shifting is actually less of a machine learning task and more of a domain task. And a lot of what I do is I'll get a question from someone from like construction or you know, a librarian, true story, will come to me and be like, well, how do I use this for, you know, dealing with books and students? And I have, you know, I walk them through, well, what do you do normally? And, you know, could that part be done by an LLM? Let's try it. And then we walk through basic prompt engineering or something like Marvin and be like, well, hey, look, it seems like it knows what you're talking about. So this could be your labels, your entity labels, your whatever. And that shifting and thinking, I think we're still pretty new there. I think a lot of people who are still doing this are people who are former developers, STEM, people who think very scientifically. But I think people who are just learning about all this stuff in NLP and LLMs, that map, again, back to that map between that amorphous thought in their head of, well, this is how I know it works, to, well, how do I map that to an LLM? That's really where it sounds like Marvin is going to help make that connection.
And Sinan, I think a beautiful point that you're making in the background here is that, like, LLMs in some sense are not, there are many things that they can do that are novel, but there are many things that they can do that are like completely not novel. Classification, entity extraction, but what they're able to meet a completely new set of users in a sense, where like they've in sense democratized access to classification, entity extraction in a way that, if you think about like the lowly analyst from a decade ago, they've spent a decade handing off small pieces of their jobs to more and more specialized folks. You know, they couldn't build a pipeline, so they handed it off to data engineers like Akshay at the time. They couldn't handle like maybe inference problems because you needed a specialist to build a model, so you'd hand it off to Sinan at the time. You wanted to be able to like do this at scale, so you would hand this off to a DevOps engineer at the time. And what I think is beautiful is LLMs like clearly are not going to solve like, oh man, they solve 100% of inference tasks perfectly, whatever. But so much of what you need to build a company or to solve a problem is like, can I get to that 80% so I can move on to the next thing that's 80%? So LLMs in some sense have repatriated some of that low-level inference work back to like the generic, technically adept, let's call them an analyst, but they have thousands of titles at all sorts of companies. Somebody who's like incredibly technically proficient, but maybe doesn't have that specialist expertise. Now this is somebody who can build a classification pipeline declaratively by saying, look, here are my labels, tell me what's up. And like I'm saying this in a very like casual way, but I think it's I just wanted to kind of double click on your point, where a lot of these things that were kind of gated behind, well, let's see if the PM can put this on a roadmap that maybe we can get this pipeline built in 2 months. I think it's going to really enable more people to build better products faster. And anyway, I think that point that you were making about, for that typical librarian who would have never had access to a data science team ever, can go sign up for like an OpenAI API key and then now start building these things on their own. And I think that's incredibly powerful.
Oh,
Yeah. I think something you and Sinan just touched on is, I think your team will thank you, right? If you're thinking about this declaratively, you're thinking about the type state matter, you're thinking about the actual metadata and excuse me, the what you're labeling those tokens and how it's structuring the output in the context of your existing business application or new one, means you're not getting mired, I think, like a lot of teams are, once they actually have customers, of the complexity scales if you haven't done planning, which is actually quite similar to traditional data engineering. Turns out if you just throw stuff into a data lake with no schema or alignment cross-functionally, it can create a lot. You can go 0 to 60 really fast. 60 to close out the final 20 is a mess, and it's not a reliable way for your end customers to use the product you're building as well. So actually aligning on that, I think one thing I love about Marvin, it forces that conversation and thoughtfulness earlier on, which I think allows for a consistent foundation for entire teams to build kind of more reliable LLM applications.
Right. Because now your LLMs, all your prompts are essentially like data models. And so if we can agree on a data model, in some sense, now you have data engineers, data scientists, product speaking the same language, which is, okay, at the end of the day, what information are we collecting here? And then it's not like this, all right, let's do this. Like, you're not having a great fracturing of a bunch of specialists. Now this is, we can all get together in a room and just actually talk about the requirements in some sense. One thing actually I'll say is like we talked about developer experience in the sense of like making working with an LLM feel like working with traditional Python. But, as we talk a bit more of like with few shot classification or entity extraction or what have you, the fact that you get to bring your own labels, one thing I'd be remiss to not mention is that when you think about the developer experience of making changes to those models, now it is as simple as saying, hey, I'm going to add this new field, or this thing was a literal of these 4 strings. Now I'm going to just add in another category that can be. And so, I've talked and advised teams that are like, all right, we're building a resume parser, and we're processing hundreds of thousands of resumes, but it turns out that a new enterprise contract that we're trying to get on the recruiting side really wants to be able to know whether or not people have at least 6 years of Python, something like this, in their resume. That's classically a very hard problem to suss out from a resume. But now, instead of saying, great, let's see if we can work on this, build a proof of concept, maybe we'll have a functioning pipeline in 3 months and hopefully the business hasn't walked out the door. Now you can essentially say, like, does have 7 years Python integer, rerun your pipeline, and now you have an LLM that's be able to do sort of deduction on a resume to say, well, I've got these many years, these many experiences. I can infer that they would use Python from how they're writing about it. Do those things add to more than 7? And like, clearly, there's some nuances here, especially when you talk about hiring and unconscious bias that comes into that. And there's some good like ethical questions to ask about that. But apart from that developer experience of, we don't have to go back to the drawing board for a couple of weeks while we retrain an entire pipeline, collect data, what have you. You can now, as simple as like, let me just edit the labels. I think that's a really powerful improvement to the developer experience in data science.
Totally agree. I think we talked a little bit, Adam, about classical examples of zero-shot classification and entity recognition, where structured output is definitely necessary and useful for what you're building. I'm curious about, as context windows expand and folks attempt to push more and more data into prompts. You're seeing this with knowledge retrieval, et cetera, and LLMs become more powerful, and folks are trying to push more complex business logic. How is Marvin planning on growing with developers there? I saw you all thinking about persistence and state, have a lot on the roadmap. So talk to us a little bit about, as business logic starts to get more complex and enterprises grow with Marvin, where you all are headed.
Yeah. Okay. So this is where like we have a very strong product opinion on this, which it might be our biggest boon, and I might be joining the pod in a couple of years, being like, boy, should have done that differently. But I think the spirit behind Marvin is this deep trust in the developer of like, we want you to be able to use LLMs in how you would have traditionally written software. And, with the exception of like banks written in like 100,000 line file of OCaml or something like this, or COBOL or something like this. A lot of folks, even without LLMs, would write bite-sized business logic that all feed into each other in a beautiful way, that each part is responsible for its own part of the pipeline. And so if we were having this conversation and LLMs didn't exist at all, and we were just like boring last generation ML people, which we have to pretend to not be, right? We'd be having the same discussion, which is like, how do you make sure that a piece of software isn't trying to do too much all at once? And I don't know if this is a question that's so unique to LLMs, and it's more like this is a deeper question about how to write good software that doesn't try to do everything all at once. But I want to take your question head on and like not actually avoid that point, which is part of the trust that we extend to developers is like, we are making a fixed set of contracts of, we will help you transpile a zero-shot classification question into something that's like bulletproof, it works, it's fast. For entity extraction, we'll do the same. But we expose some ergonomics here to where, if independently you want to take in a user query, like let's go back to that example that Sinan brought up earlier, right? Like, or I'll take the ridiculous example that I gave of like, I've got a location model that's got latitude and longitude, and I put in that I'm from the capital of the Midwestern state that has a unicameral legislature, which is I'm sure all of you knew before this pod, is Lincoln, Nebraska. And but there's a world where an LLM doesn't have access to that. As omniscient of an autocomplete as GPT-4 is, you can imagine that we're going to be working with some demigod versions. Maybe Llama 2 doesn't actually know about the state legislatures of Midwestern states. So what we enable developers to do is like, great, retrieval augmented generation is a thing. We don't believe right now that like we have to do all of this for you. So you notice that I think a distinction from Marvin is like, we don't try and do everything for you. We try and lay out a series of highly consistent contracts of like, if somebody says that they're from the Midwestern state capital or something like that, with a unicameral legislature, if you would like to independently go and look up Wikipedia for like fun facts about U.S. state capitals because you have a prior on what your users are going to be telling you about that, like you can build an actual lookup system with a classical vector store, and then you can feed that in as context to our sort of low-level API, which is it's responsible for taking context and a schema, and it's responsible for outputting structured text. And so we may get more opinionated as we grow a bigger tent, but right now I think one of the reasons why people really enjoy using Marvin is that like we give you this base set of core components or primitives that you can stitch together how you'd like, and we don't have like from Marvin dot Midwestern capitals dot classifier dot extractor import Midwestern extractor, right? And we don't say, great, let's dump something in there and we're going to do a vector lookup on your behalf to some random Wikipedia corpus we decided is important. That it's more of like a belief in, if a developer wants to build in that RAG system, they should do that independently of the primitives that we expose.
Super helpful.
Nice.
Well,
Yeah.
Adam, that's a great overview of Marvin and how you're helping a ton of developers. Super appreciate you coming on the podcast, and want to clarify that no elephants were harmed in the making of this podcast. But thanks a ton,
Thanks.
Adam. Really appreciate you coming
All
on.
right. Yeah, appreciate your time. Thanks, Anand and Oxley. Appreciate it.